Okay, and actually, this will be good right on top of this. Perfect.
Are you doing multiple?
Yeah, I always do more than one because
That's good.
hedging my bets. Because if one battery goes dead, I at least have.
Do you edit too?
Yeah,
Oh,
yeah.
good.
I use OpenShot, which is a freeware software package. Really nice. Okay, so that's. Let's make sure it's all going. That's good, and I'll be on your right side there in a second.
What's that one?
This one's an LG phone,
Oh,
also with a really nice 4K camera.
oh, that came in handy, that chair.
Yeah. The nice thing is it came with a little extra screen thing that I use as just a tripod to be able to hold. So, okay, I'll stove over here and it's Schlussler.
Yeah.
Okay, great.
Schlussler.
Okay.
The sun here is, oh, sorry.
Yep.
Let me see if the sun's going to hit the panel. So you get there's no direct sun. Oh, here it is. See, there's a bright spot here.
Okay. So you're going to have this pointed that way then?
Yeah.
Okay, because I'll have to move these.
Can you do a close-up?
Yeah.
Of a little spot?
Yeah, I'll be doing with this.
You got to do it quick because the sun's going to disappear.
Oh, yeah. That'll be good. And we'll have this, well, I guess I'll be on your left then since you're there. And this will be good. Okay. I usually do my intro and then we do the
Well,
questions.
let me show you first. See this little,
Right.
see you get the bright spot?
Mm-hmm.
You can see it better from the other side.
Okay.
Right here, is
Sure.
the bright spot.
Sure. Okay.
The leaves are moving.
Yeah.
In
Yep.
front of the camera.
Sure. Okay, so we'll get going. I'm Luther Kruger, Big Blue Sun Museum, Solar Cooking, based in Minneapolis. I'm with Larry Schlussler in Arcata, California.
Yeah.
Yeah, and good to be here. Thanks so much for having me. We both presented at Console Foods, so we're kind of brothers in arms with solar energy. And I always have three open-ended questions.
Okay.
The first one is, going back, when did you first get into solar energy, any way, shape, or form, and how did it get to the point where you were thinking about cooking with the sun?
Well, I was in Canada working, I was a postdoc, and I was working on something totally different. And I met a guy that did passive solar,
Okay,
and he started teaching me about passive solar.
sure.
And then, I don't exactly know when I got interested in solar cooking.
Somewhere in between then and now.
Yeah, right.
Yeah.
But I've always been interested, my main interest is sustainability and doing things efficiently.
Sure.
And then maybe a friend of mine wrote a book on the history of solar, John Perlin.
Oh yeah.
Maybe you know him.
I don't know him. Was it the Golden Thread?
Yeah.
Oh man, yeah, I give that out to people.
Oh, really?
Yeah, basically as a thanks for, contributing to the video series and sharing the stories. So yeah,
great.
I got 2 or 3 in my car right now. You'll see them.
Great.
Yeah.
So my old girlfriend edited his book.
Oh, nice. Okay.
Yeah. So I met him, and then I learned more about the history of solar,
Sure.
and probably saw some stuff on cooking
Mm-hmm.
in that book.
Sure. 'Cause some people can pinpoint it, and some people it's like, well, do you remember the hot dog cooker in high school, or
Yeah.
and then later on they saw an actual commercial model or something.
Mhm.
Yeah. Well, so now currently you're working on what kind of solar cooking apparatus?
Well, I keep jumping around,
Yeah.
but my latest thing is solar electric.
Uh-huh.
Solar's gotten so cheap.
Yes.
When we started, we built refrigerators previously. And when we started, solar was maybe $10 a watt or more. And now someone told me you could import large quantities to Africa for 20 cents a watt. So, like, say this is 380 watts, so this would be pretty cheap.
Oh yeah. Yeah.
It's amazing how cheap I don't know how they do
Yeah. So maybe we don't want to know.
it. Yeah, right.
Yeah.
Yeah,
Yeah.
exactly. So this This panel is 380 watts,
Mhm.
and it's on a manual tracker,
Mhm.
so you can point it at the sun.
Right.
It's real easy to move it.
Sure.
So like sometimes, say we're cooking beans,
Mhm.
what we do, it's really simple. We put them in the pot the night before. Well, let me first say, we're doing two kinds of solar electric cooking, with and without batteries.
Right.
I started doing solar direct, and then I also added the batteries to the system. So if you're doing solar direct, no batteries, what you would do is point this at the morning sun,
Oh yes.
which is behind these trees. And then you put the beans in the pot the night before.
Mhm.
They'd be pre-soaked overnight. And then as soon as the sun comes up, they start cooking automatically. And then 3 or 4 hours later, they're totally cooked.
Sure.
So it's really convenient.
Yeah. Yeah. And now, inside your workshop,
Yeah.
you must have your. Is it a phase change material or?
No, we don't use any phase change materials.
Okay.
I don't know why other people don't do this.
Mhm.
I asked some fellow at the conference that did storage, and he didn't use it. You have this, one of the best storage mediums is water. The food chain is water.
Right.
So just the food itself is good for thermal storage
Sure.
if it's well insulated.
Sure. Okay.
So that's really all you need.
Okay. So we'll move the cameras in there because that's where that project is. Okay, give me about 30 seconds so I can get these all hung up, and then we'll plenty to talk about in here.
That's what I don't.
Yeah. Okay. And this, I'll go here. Hey, this will be good.
You could do a shot if you wanted just a general shot. See a little junk in here.
We'll be getting that with the.
Gizmos.
Yeah, this will get that because it's fairly wide.
Okay.
Take a look to make sure. Make sure we get you in there. That'll work. And bring this guy in. And this might actually.
What do you need?
Oh, just somewhere to set it. So hold it up here, and then we'll talk about this first, and then that, or we tie it together.
No, I didn't want to put this in.
Okay.
We could just have this. These.
Okay. Yeah, let's do that, and then I'll put this here.
Okay.
Okay. Yeah. Okay.
So I'm going to be moving over there too.
Okay. Yeah. Hang on a second. I'm gonna turn this on because this will be doing my.
I can move this
My
thing.
sound. Okay.
I need a good spot for it.
That'll be good. Yeah, right there's good. So, give me another second here. This guy, he will have, actually, switch that, and we'll do this. And this will probably work. It's a little extra, and it'll be mostly for our sound anyway.
I don't want to see myself.
Yeah, yeah. Okay, great. So what do we have going on here?
Okay, so outside we have the power source,
Mm-hmm.
the 380 watt module. And then for doing solar direct cooking, what we have two wires that come from the panel. And then they go to this gadget here, which is it's called the maximum power point tracker.
Okay.
It's like a gearbox on a car. It adjusts the voltage so the panel is always putting out its peak amount of power.
Sure.
And then all it's the power system, you just plug in a 120 volt heating device, like a hot plate or any various thing and stuff. And
Sure.
that's all that's to the whole system.
Okay.
So, let's see. Then we also, then what we cook with, we do a lot of, somehow it's been overlooked a lot, retained heat cooking. You can do it really conveniently. They used to do it, there used to be commercially available retained heat cookers in the early 1900s.
Oh wow, back then, yeah.
Yeah, and then they kind of disappeared.
Uh,
And then now they still make, they're more popular in Japan and the East, but I don't think they're widely popular. So we cook in various devices. Like this is one of them.
Sure.
You've probably seen these things.
like Instapots.
Instapot.
They're pretty popular, yeah.
Rice cooker.
Yep.
So with this, these have hollow walls and a hollow top. So in electronics. So what we did, we took all the electronics out, and then we insulated the walls. For some reason, they don't insulate them.
Oh really?
Yeah. And then in this hollow space in the top, we insulated that too. So it works as a retained heat cooker.
Sure.
So you just plug it in, you bring it to a boil, and then you turn it off. And then the heat, retained heat cook, finishes the cooking process.
Sure.
And then you could use, while this is cooking, you could use the panel to start cooking a second dish.
Sure.
And then these are some other retained heat cookers. This is made by Thermos for a different purpose, but this is evacuated. And so you can use a hot plate, just have a hot plate, and then you put this over the top. And when it comes to a boil, you shut off the power, and it cooks itself.
Sure.
And then this is a larger one.
Oh yeah, yeah.
This particular let's see. We also have what I'm doing right now. We've got this oven. You came here after the sun was no longer
That's
hitting
okay.
the panel. So we did heat it up this morning with direct, solar direct. But we also, we have the switch, so we can either go solar direct, or we can shunt the power over to charge a single battery.
Sure.
It's about 100 amp hour lithium-ion battery.
Yeah.
And so that's what I did. I charged that up. And then, now I'm heating it up again. It only takes 125 watts to keep it at 350 degrees.
Sure.
And the panel's 380 watt.
Yeah.
So usually, but because of losses and et cetera, when it's clear sun, it puts out about 320 watts. So you have more than enough to heat the oven up. So now to use the oven at night, we don't have enough thermal mass in it to keep it hot all night. So what we did, we charged up the battery, and then the battery goes to a small inverter, and then this is just a transformer. It's a variable transformer.
Sure.
So usually if the battery holds a kilowatt hour, 1,000 watt hours, for efficiency, you don't want to take out more than about 500 watts. So I can adjust the voltage output so it's putting out about 500 watts to get it heated. So now it's up to 375, and it's heating up.
Sure. Okay.
And then what we did, we took a conventional oven and insulated, added more insulation. We also put aluminum foil on the inside. See, what that does is a lot of the heat given off by the heating element is infrared heat. And if the sides are black or painted or not a shiny metallic substance, what happens is the emitted heat goes to the sidewall and is absorbed by the sidewall. And then it heats up the sidewalls, and some of it will conduct out into the room. And then This way, it also makes the heat a lot more uniform.
Mm-hmm.
Another thing we did, we sealed up all the holes in the oven. So, like when we're cooking, I can cook some cornbread tomorrow. It keeps the cornbread really moist. A lot of ovens will dry things out. I'm not a real chef, but I know for baking,
Yep.
lots of times you want to contain moisture.
Yes, yes.
Especially for bread to start it.
Yep.
Get the rise in the bread,
Mhm.
the initial rise. We also have a whole variety of appliances we can put, connect to this electric system.
Sure.
Either the battery powered or the solar direct. Like you can, for doing frying where you need a high temperature, if you've seen George Foreman cookers.
Yes.
So those are really good and efficient because they heat the food from the top and the bottom. If you just have a frying pan, you have this hot surface and it's just radiating heat
Right.
into the room. And then the George Foreman cooker will cook food faster and more efficiently. Unfortunately, they don't insulate them for some reason.
Yeah, that seems to be a common theme. They don't worry. They don't worry about it. They don't worry about the consumer saying, "Boy, this would be more efficient."
Because the consumers, that's one of the problems. All the appliances, electric appliances designed for the developed world,
Yeah.
people that purchase them don't know how much energy they use for cooking.
Right.
And they won't know how much energy they're using for the device. But a lot of small appliances you buy, if you touch the surface, it's real hot.
Yeah.
And there's danger signs on it. Don't
Yes.
touch these hot. Because they don't insulate them.
Yeah.
They're totally uninsulated. So,
A quick question on
Yes.
the aluminum. That's a what do they call it? A radiant barrier. So it is able
yeah,
to-
it's like a radiant barrier.
Yeah.
A
Okay.
radiant barrier does the same thing.
Yeah.
It reflects infrared radiation,
Mhm.
but also if it gets hot, it doesn't re-emit the radiation. Like if you had a wood stove made out of shiny aluminum,
Mhm.
you wouldn't feel any radiation coming out of it.
Okay.
Because it's a poor, things that are reflect are also poor emitters of infrared radiation.
Do you know Ed Pijak?
No.
He was a founder of SCI, Solar Cookers International, back in the late 80s, early 90s.
I might have heard of him.
Yeah, and he was a professor at University of the Pacific in Stockton,
Okay.
and he organized the first conference that SCI held, international conference.
I might have been there.
It could have been.
Was that in Sacramento?
It was actually in I believe it was in Stockton.
Oh, Stockton, right.
Yeah, yeah.
I went to that.
Yeah, okay. Then you probably rubbed shoulders with him because he was probably master of ceremonies for part of it. And, tall guy, but I remember when I interviewed him, he talked about how before he came out west, I think he was out east and was in not cryogenics, but real ultra low temperature freezing of things, down to near absolute zero.
Mhm. Yeah.
And his boss had said, you know, if you you froze something and you lined it with 500 layers of aluminum foil, the question was, how long would it stay frozen? And the answer was 100 years. Or if it was hot coffee, how long would it be hot? Like 100 years.
Maybe.
And I don't know. I mean, I'm not a scientist, but
Well, you know, heat's conducted three ways: convection, conduction, and radiation.
mhm.
So all those radiant barriers are good, but you still, unless you evacuate it,
Yeah,
you still have the air in there. So the air is going to act as a conductor, and it's going to
Sure.
go through the air. Air's about roughly R5 per inch
Mhm.
thickness.
I
If
think-
it's totally still.
sure. I think he said some of the things that they froze near absolute zero, it was aluminum foil, very thin layer of paper, aluminum foil, times 50 or 100 times. And I've been
Did
starting
they
one.
evacuate it?
I don't think so.
Oh,
But apparently that was they were able to do some kind of manufacturing process to do that, so they could do samples
mhm.
without having to have 500 people gluing and whatever.
Well, these things here
Mhm.
have a vacuum. Plus, walls are aluminized.
Okay, so that one doesn't.
To suppress radiation.
Sure.
So you could have a vacuum, but you're still going to transfer heat from the inner wall to the outer wall by
Right.
radiation. But if you coat it with aluminum, then you eliminate the radiation too.
Sure. Sure.
So, I don't know, there's been papers like 30, 40 years ago on lining ovens with aluminum, but
Mhm.
people just forgot about it.
Sure.
Like, I don't know why appliances are so badly designed.
I have a theory, and I won't put it. Leave it in the power companies don't want you to make them efficient because they want you to pay more for the power.
No, I don't think it's the power companies. The electric companies, they just want to build stuff cheap and
Right.
put things that consumers might like.
Yeah.
But
Yeah.
efficiency isn't one of them.
No, and you're right. I mean, we put 6 kilowatts of PV on our roof 7 years ago, and the first thing I did was I could check it on my phone how much we're using and how much we're generating. I mean, the sun rises, it starts, and by noon it's about just short of 6.1 kilowatts, and with full sun. And then when the clouds come in, it kind of gets jagged. First thing we noticed was our electric clothes dryer was like 5.5 kilowatts. So we said, okay, we're quitting that. I haven't unplugged it and thrown it in the alley yet, but we now have more clotheslines than we ever had.
Wow, that's good.
We've got those clothes racks. Yeah, Minneapolis, yeah.
That's nice in the winter when it's frozen and,
Well,
and you got it out in the sun and still
we
dries.
could, it would. It probably would. We're like, what do they call it? Sublimate. Or go right from, yeah. But we just put the racks up on our third floor, and in the winter it gets they're so dry.
Oh, it's
that
too dry.
It dries almost faster just inside the house.
I see.
Without the sun because the air is so dry.
Do you have an old house?
Yeah.
Oh,
1899 fixer-upper.
Oh, it's leaky.
Yeah.
A leaky house is going to be low humidity.
Yeah, yes, very much so. We had to add a humidifier and I forget what else, so we wouldn't brush against each other and give a big static shock.
Really?
Yeah. Or doorknobs.
I lived in Calgary for a while.
Oh, there you go, same deal, right?
I had that problem.
Yeah.
Yeah.
Well, cool. Anything more on this that
you'd
like to share?
We did try deep frying a few days ago, and that worked pretty well.
Good. Yeah.
We could get it hot enough. So you can do. We also did one of the unique things in the oven is we built a pizza stone. You know, like if you don't have a lot of heat, a lot of watts,
right,
you can store the energy in something like a pizza stone, and then it puts a burst of heat into whatever you're cooking.
Sure.
So we made it. I don't know why other people haven't done this. We made it out of aluminum because aluminum is a good conductor, and it actually stores quite a bit of heat per unit volume. So it works pretty good. So we got this aluminum stone in there.
Okay.
Red stone.
Yeah. How thick is it?
It's about 3/16.
Oh, okay. So just short of a quarter inch.
Yeah.
Okay. Because you have probably been in contact with Pete Schwartz or Barry Butler or those folks that are doing much the
They
same
have a
thing.
different approach.
Yeah. Because he had been doing the phase change with salts and erythritol and but there's students, and he toward the end of it I guess it was a 6 or 7 year program, and he just went on sabbatical to try to plant the seeds for people to just produce them in Africa, and they switched to just this big cylinder of aluminum. It must be 6-8 inches tall and maybe 6 inches in diameter. And then a heating element that they fuse pretty much to the bottom with a nichrome wire thing.
Oh yeah.
Just from a electric stove replacement.
But I wonder if they do maximum power point tracking.
He does. I don't think he does, because at least in his home he just had a solar panel. He said, I could
direct to the heating element.
Yeah, but it's direct to the heating element. Yeah.
The trouble with that is when it's full sun, if you just design it right, it'll work good. But say you had half sun, you'd be theoretically you could produce half as many watts. But if you don't have maximum power point tracker, you might only produce 1/4 as many watts.
Oh, really? Okay.
So you lose a lot.
Mm-hmm.
You can figure it out if you look at the curves
Sure.
for solar panels.
Yeah. I think
IV curves.
he's one, and he's insulated this block, and
Yeah.
and then the pot goes on that. I think he said, and I've got it on my channel, that overnight it retains enough heat where it doesn't take that much once the sun rises and just hits this panel that hasn't been tracking to bring it back up. It takes longer, but once it is, and then like at high noon, of course, it's full power.
You know, one of the things that's lacking in solar cooking is knowing it, not only solar thermal and solar electric, but just different kinds of clean cooking, is knowing how much food you can, if you're going to invest in this cooker, knowing how much food you can cook in a day.
Yeah.
Like the Solar Cookers International,
Mm-hmm.
the test doesn't really tell you how much food you can cook in one day.
Right.
And also at the conference that we went to, they found an error.
Yeah,
In
Celestino
the
Rigo and his
testing.
team.
The thing is that they didn't consider is solar thermal cookers become less efficient when the sunlight's.
Right.
Say you had full sun and you're collecting 1,000 watts.
Mm-hmm.
If you have half sun, ideally you'd be collecting 500 watts. But a solar thermal cooker loses its efficiency, so you'd be collecting less than that.
Mm-hmm.
And the worst ones are panel cookers
Mm-hmm.
without any glazing. And then evacuated tube cookers are pretty good
Yeah.
because the high temperatures, they don't lose that much.
Sure. Well, and the panel cookers that seem to be the most popular and well received, like the Haynes, he has a polycarbonate sleeve.
Oh,
for the
he
heat trap.
does have glazing.
Yeah, yeah, and then on top of the glass lid of the pot that he provides, a stainless steel pot,
Mhm.
he also has another layer of the polycarbonate, kind of a cone, just
Well, that's
to
good.
take a little bit of the wind friction off, or reduction of the heat due to wind.
Oh yeah, that's
Yeah.
a good feature.
Yeah.
You know, when we started solar direct cooking, let me see what it is. It's
Oh. Almost to
50.
400, huh?
Well, it's over 400.
Oh, oh, right. I was
I'm going to turn
Oh,
it
man.
down.
sure.
So, when we started solar direct electric cooking, I was wondering, you know, how does this compare with solar thermal?
Sure.
How would you know if you want one or the other? So what we did, you might have suggestions. We made a list of maybe 15 points that you want to know when you're cooking, like how long does it take to boil a certain amount of water?
Right.
How long does it take to get it up to pasteurization temperature? Can you cook inside? In the developing world, a lot of times they like to cook inside.
Mm-hmm.
Will the thing work on cloudy days? Like solar PV is pretty good on cloudy days. You still can collect energy. It doesn't lose efficiency like a solar thermal cooker. Say the sun goes down, it's 50% less efficient,
Mm-hmm.
less intense.
Yeah.
It's going to put out about 50% less watts,
Mm-hmm.
whereas a solar thermal cooker will put out less.
Mm-hmm.
Does that make sense?
Yeah, well, yeah. I mean, I slept through all my science classes. I trust you. I trust him. No, I mean,
No, you shouldn't trust me.
Well, where this goes up, there will be obviously there's going to be some exchanges of ideas and all that. And you presented on this at the Cosmo Foods Conference, so.
But yeah, the Calistino, what's his name?
Celestino. Yeah.
He's the one that discovered the error.
Yeah. Yes.
But before that, I was complaining to Solar Energy International that their standards really didn't tell someone how much food they could cook.
Mhm.
Because they measured the wattage it produced at pasteurization temperature, which is a fair amount below boiling.
Mhm.
And some cookers could make it up to boiling with little loss. And like a panel cooker with no glazing at all, might not even make it up to boiling.
Hmm.
So it doesn't give you a good idea of the relative performance of
Sure.
different cookers.
Have you seen Matt Alonso's presentation on the sun buckets? And I mentioned that
Oh,
because
yeah. I was interested in the sun bucket.
yeah.
I tried to work with him, but I wasn't successful.
Oh no. Okay.
I wanted to see if we could heat it up with the
Oh
solar
sure. Yeah.
electric.
Yeah. I actually had ordered one when they had an executive director that was
Yeah.
wanted to promote the purchase of it in the States, not
Uh-huh.
just in the developing countries, and that it didn't work out. But he has a presentation where he shows here's the sun bucket fully charged, 2
Yeah.
or 3 hours in that parabolic
Right.
upside down. Then he puts it on a table wherever, a liter of water, maybe 15, 20 minutes
Mhm.
to boil, and take that off right away. Put that maybe in a retained heat cooker.
Yeah.
And the next one, that might be 22, 25 minutes because it's starting to lose a little bit.
Mhm.
By the time it was maybe 2.5 hours, 3 hours, I don't remember the exact amount, but it was 7 liters of water brought to a boil in the space of 2.5 hours. Could have been inside once it was fully
Uh-huh.
charged or wherever. And that starts to speak to the volume of food. Because if you figure,
A little bit.
yeah, like a liter of soup or a liter of stew.
Right.
Yeah.
You know how much water you can lift.
Yeah.
One of the things about the sun bucket in the parabolic dish is another point of consideration if you're comparing, say, solar thermal
Mhm.
cookers and other types of cookers, is how often you have to move it to keep track it. Like
Right.
any cooker that has lots of reflectors, you're going to have to track it more often, like a parabolic dish. So you're going to have to, you're heating up that sun bucket, but you're going to have someone there
Yes.
moving it quite often, 10 minutes or whatever.
Yeah.
So it takes a lot of labor. And my thinking is you might as well, if you're making, like you said, 5 quarts or 6 quarts of hot water, you might as well just heat up the water, and you can even store it overnight. And it'll be hot in the morning
Yeah.
if you have good insulation.
Sure.
So you don't, I don't know, and then some of those phase change materials might have their technical problems.
Well, yeah.
Corrosion
In fact,
and long life.
yep. In fact, even sun buckets put aside the salts that they had really kind of banked on,
Mhm.
partly because of the expansion contraction and
Right.
apparently a kind of a crust formed on one side that kind of insulated the rest from
Oh, right,
heating
that
up
makes
enough.
sense.
And so they went to the aluminum because it eliminated the whole, expansion contraction is
Right.
minimal. They didn't have to.
It's a real engineering
Yeah,
problem
yeah,
to make that work.
yeah. And they all gave up on the sugars, the erythritol, because that broke down after.
Yeah.
So Pete Schwartz's student talked about that, how
Mhm.
maybe 80 or 100 times pretty good, but then they just started to see
Oh, gosh.
pretty steady.
Once that, and the nice thing about the PV is it can last 25 years.
Yeah.
So anyway, I should mention, even if you do in solar direct, you can, like if you had a family of 5, you could, if you have some direct sunlight, you could cook all your food in maybe 3 hours.
Sure.
Let me turn this down. And then you have all that electricity available to do other things.
Yeah.
Like right now, we're running a refrigerator,
Sure.
a 4 cubic foot sun frost
Mhm.
off the panel. And we could do it, this refrigerator is designed so it doesn't need a battery.
Mhm.
It can work direct off the solar panel. Or we can hook it up to the battery.
Sure.
And it has enough insulation and thermal mass so it stays pretty cold overnight.
Sure. Have you worked with induction cookers in your system?
I have.
And you're laughing because they're not really good, or you're not.
No, because they get in cooking, there's certain devices that get all this publicity.
Right.
And like, people go crazy about it. Like my neighbor across the street, he's got 50 amp service, and he's getting an induction cooker, and he's got to change it to 100 amp service, which is insane. That means he's using 11,000 watts for his stove. Like, we're keeping this oven hot for 125 watts.
Mm-hmm.
So induction cooktops would, resistance heat, like these things,
Yeah.
or just a resistor,
Right.
it changes 100% of the electricity into heat.
Mm-hmm.
So if you had a well-designed pot, you could even make the bottom of it thin. You don't have to have a thick pot. If you distribute the heating elements over the entire bottom of the pot,
Mm-hmm.
it would be totally, so you'd save on materials and weight.
Sure.
And it would, and all the heat you generated, you just have to make sure that the heat you generate goes into the pot.
Mm-hmm.
So you have to have insulation below,
Sure.
and you have to make sure you have good thermal transfer. So because resistant heaters aren't designed well to be efficient, and it would be super responsive. Induction cooktops are responsive because they can use 2,000 or 3,000 watts.
Right.
If you had a resistance heater that could go up to 3,000 watts, it would be just as responsive, maybe more so. But the thing with induction cooktops is what they do is they have some electronic gadgets in there and they have a coil of copper
Mm-hmm.
to make this magnetic field.
Right.
And then the magnetic field puts the heat. So when you have the electronics, they're not 100% efficient.
Right.
And then you have resistance in the coil. So you have wasted heat. And people think all the heat goes into the pot, but actually the pot is sitting on this surface. So the surface it's sitting on gets almost as hot as the pot, as the pot heats up. And then to protect the electronics and coils inside, they have a fan,
Right.
which is noisy. A lot of times if it's not built, it's noisy.
Yeah.
And then if you use it in a developing country, I don't like the idea of having fans because bugs can get in there and it can break and get clogged up.
Sure.
So actually resistant heating is a lot better, but it's just because appliances haven't been designed well. Like the way we modified this is pretty good use of resistance heat. This Instapot.
Sure.
So we can get almost all the heat into the. Well, you know what works really well is a common thing where you heat it up fast is an electric tea kettle.
Right.
My electric tea kettle is 95% efficient, and I have an induction cooktop. It's only 77% efficient. I could measure it. I could just heat up a quart of water to boiling, and I could measure both of them.
Is the electric tea kettle that's just a heating element, not induction or anything else?
No, it's just the thing is there's really good thermal contact
Right.
between the water and the heating element, and it's not insulated, but because it cooks it up, it heats it up in just minutes, 5-10 minutes or something.
Sure.
You don't lose a lot of heat by radiation or conduction or whatever.
Right.
And if it's a shiny pot doesn't emit as much radiation
Okay.
as a colored pot.
See, because we have one of those, and I always thought maybe that little thing that comes up into the bottom is a tiny induction.
No, it's
element,
just
but it's just
an electric resistance.
well, so if I were to turn it off, take it off, and do my infrared thermometer on it, it would be pretty darn hot. Right?
Yeah. Well, you got to make sure it's dirty. Because if it's shiny, infrared thermometers don't work good on shiny surfaces.
Oh, right, okay. Because it looks like it's a little tiny.
Because
copper.
it's just measuring, because aluminum reflects
Right.
infrared, so you're just measuring the reflection.
Mm-hmm.
It's like if you had a mirror
Yeah.
and you point it at a light meter and you wanted to,
Mm-hmm.
you'd just be seeing the reflection.
Wow.
But I don't like infrared. Also, I don't like, there's a group called Modern Energy Cooking Services. Have you heard of them? They do a lot of work in the developing world, and they get money from the UK, the government, and they do a lot in Africa. And one of the things, they try and push electric cooking. So it really gets me aggravated. Like in an article they wrote initially, that we shouldn't be pushing modern cooking methods because they're all flawed. And their example was using gas, induction cooktops, and pressure cookers. Like just recently in Great Britain, this report came out and showed all the health consequences of cooking with gas, which are getting more popular now, and people are getting to know about them. Nitrogen dioxide and all this other stuff. that goes in the air. So we shouldn't be pushing that, and they're pushing induction cooktops and pressure cookers. And pressure cookers, one of the things that's important is a concept is that if something cooks fast, it doesn't mean it's convenient or efficient. Those are all separate concepts. Like I described cooking the beans out there, if I'm only putting 300 watts into the beans instead of 1,000 watts, it's real convenient. I don't have to stand there watching it. I just come back when it starts boiling and turn it off. That's about all I have to do. So it doesn't mean, with solar cooking, you know, you can put a box cooker out in the sun and point it where it's going to be in the afternoon and then come back in the evening and your food's all cooked. So convenience doesn't always match with speed. And then another thing about those pressure cookers, well, they cost more than just a resistance heater. But you're heating it to a higher temperature, I think. Instead of 212 degrees, you have to heat it up to 240. Plus you have all that mass and extra structure to keep it from exploding.
Right.
So you have all that extra weight that you have to heat up to the high temperature. And then when you relieve, actually this is interesting, when you relieve the pressure, so you got all this water superheated to 240 degrees, and then you take the jiggle thing off the top, the pressure goes down to normal atmospheric pressure, and then instantly the pressure drops down to 212 degrees, the temperature. Right. So all the extra energy that you put into that thing to bring it up to higher temperature went into evaporating the water. So the steam coming out of the pressure cooker represents all the excess energy you put in to cook your food. So, and you can, if you do retained heat cooking, you can, I think if you looked at the amount of time you have to spend and the convenience, it'd end up being better.
Yeah. We do that. We still have a gas range and we have an induction range, but we also have a bunch of the solar thermal cookers. And inside, when we cook on the stove, we will often take it off as soon as it's been boiling for a few minutes and put it right into the hay basket, the Wonder Bag. So it's just basically rags stuffed in a big puffy.
Right. Those are good.
Yeah, and if it's maybe 2 or 3 in the afternoon, it'll still be piping hot by the time we have supper. So, yeah, we try to do that so we reduce the amount of gas that we use.
Yeah.
It being a really drafty house, the buildup of the toxins isn't as much
as
these modern homes that are all sealed up. People are hurting more.
Right, in a modern home is more of a problem.
Yes.
Yeah.
But we'll do it outside too when we remember. But again, we're really trained to not worry about efficiency. So you just say, well, just let it boil. We're busy doing stuff in the house, so we don't worry about it. But if you're talking about a family, a larger family or a bunch of families relying on 1 or 2 devices, efficiency starts to really.
Well, especially in developing world.
Yeah.
Because that's, in some countries, cooking is one of the biggest energy uses.
Yes.
In the country.
Yeah, almost the only significant energy use.
Yeah.
Right? I mean.
Even on a national basis.
Yeah.
It's a good proposal. So what we're doing, you mentioned retained heat cooking. We call these retained heat cooking 2.0 because we're insulating it while we're heating it up. And then you just shut the power off and it's still insulated. You don't have to move it to the Wonder Bag.
Right.
So we want to make it more convenient.
Sure.
And
Well, this is great. I can't think of any other questions about this. I guess the third question I always have is, and I think I can know the answer that you might give. I'm going to guess.
Yes.
What's the future? What do you see as the future? Both, your opinion on what people should be doing, or what trends are happening now that you're seeing. Anything like that. Open-ended.
Well, we've been trying to do cooking for the developing world.
Right.
That's one of my main focuses. But the problem is, those people don't have any money. They're only having a couple dollars a day or something, and they can't make the big investment It's not so big now, but in the solar panel and the equipment. So, but I think with financing, if there was some kind of microfinancing, but someone has to stick their neck out and find out how to do that. You know, even in this country, anytime you have solar, like for a utility or for a home, often people get loans. They don't just pay for it in one lump sum. So I think you got to do that. If you have some sustainable cooking method that's going to last for 20 years or more, it might take a little bit for financing. One thing we've been looking at because of the financing problem is we've been looking at alcohol cooking with ethanol. But someone has to stick their neck out and find out how to do that. You know, even in this country, anytime you have solar, like for a utility or for a home, often people get loans. They don't just pay for it in one lump sum. So I think you got to do that. If you have some sustainable cooking method that's going to last for 20 years or more, it might take a little bit for financing. One thing we've been looking at because of the financing problem is we've been looking at alcohol cooking with ethanol, which can be made sustainably, and it's easily transported. It has a lot of advantages. It doesn't put out a lot of pollutants when you burn it, and you can make it sustainably. And the stoves are cheap. So we're looking at ways to do that efficiently.
Are you in contact with Tom Sponheim about that? Because he's doing.
Who's that?
He was the wiki. He started the SCI's wiki before there was even a wiki, and he's been on the board. He's now doing a project in Kenya. I forget the name of it, but I can send you the information.
But, yeah, I'd like to get it.
Yeah.
I'd like to be in contact with him.
And the one thing he pointed out, he said, well, you know, in the 1900s, early 1900s, farmers, they make their own fuel because they distilled their own alcohol, and were able to, you know, do all sorts of maybe modest things. I don't know if they ran any engines of it, but
they could.
Yeah. So they promote all sorts of things, but one of the big things is it's an alcohol stove. And then they just get manufactured alcohol for it. I don't know where they get it, but it's apparently inexpensive.
They do make it, and they make it in the developing world.
Yeah.
But a lot of people think when you make alcohol, like if you made it out of a crop like corn, that you're losing food value. But alcohol just contains carbon, hydrogen, and oxygen. It doesn't contain any nitrogen or minerals. So actually, they call the stuff left over after you make the alcohol, it's the stuff left is fermented, which is more easily digested by cows than pure corn. So you still have a good food crop.
Sure.
But in the developing world, there's other products, things you can grow that are probably better than corn. Maybe sugar cane or something, sugar beets or something like that.
Yeah. So you'd like to see more of this, which it makes total sense because, and for me, even at home, when like we might have 5 or 6 or 7 guests, and I want to do 7 or 8 dishes for them to choose from, and the sun doesn't come out till about the clouds don't clear until 11, so I have 4 or 5 hours to cook for dinner. Right. So being able to cook several dishes, I basically put out several cookers.
We had a whole museum of cookers.
Yeah, exactly. Yeah, I got my choice. But to know about the insulation factor has never been an issue because I usually do have enough time. As maybe we figure, well, we'll cook solar today because it's going to be sunny all day. Then until I retired, I had to show up at a precinct station where I worked, and Joe has to work at a hospital, and COVID got us a little bit more flexibility, but when we were at the office, and I checked my phone to see what our solar production was, and I see, oh man, we're wasting solar energy because we're not cooking with it because we're not home. Yeah. I mean, it's a little twisted attitude because, of course, since we're not home, we can't cook there anyway. But anyway.
You know, if you are cooking a large amount of food, like in the developing world,
Mhm.
I think they call it institutional cooking.
Mhm.
Is that for schools and stuff?
Yeah.
You know what works great is the larger the volume of food you have, the easier it is to keep it hot for a long time.
Mhm.
So like if you were cooking for school and you're doing boil and simmer cooking, you could work on it in the afternoon the day before, and then you just put it in this insulated container and you'd have hot food the next day for lunch.
Sure.
So it's a really good way to go, but it's been overlooked.
Yes, yes, I will say. I mean, totally agree on that. Okay, well, maybe we can look at a few things outside. I see.
Oh, here I can show you some more stuff.
Oh, sure. Yeah. What you got here? Yeah. Oh, man, goodness.
This is
Look at that too.
we built this about 15 years ago.
Mm-hmm.
This might be the first large diameter solar oven,
What's the interior diameter?
about 4 inches.
Okay.
Well, large, you know, over those little ones.
Sure.
Actually, we saw this solar cooker. You might know this company. We used to go to the Midwest Renewable Energy Fair.
Right.
Do you ever go there?
Yeah, I was at the last one just in June, or
Oh,
May,
cool.
or June, yeah.
But we went there, and this guy next to us had a booth. He was from Minneapolis.
From Minneapolis.
Yeah.
What
And
was,
he
you know his
had
name?
this booth, and he was selling these tubes for making hot water. And what was interesting, you put the tubes vertically,
Mm-hmm.
so they get hit by the sun in the morning and in the afternoon. And then I looked at those tubes, and I was building some solar cookers from those little tiny diameter tubes.
Sure.
And then I said, wow, I could use that for a solar cooker. So I got one from him, and I built a couple of cookers.
Mm-hmm.
Since then, we built a whole variety.
Sure.
Like this is one. I broke the tube.
Oh,
But
that's where it went and the reflectors would.
yeah,
Goose up.
this is another one. we
Yeah.
got. But this one worked really good.
Mm-hmm.
I can pull it out. We wanted to build other ones that were more convenient.
Mm-hmm.
So all these surfaces, we don't have a parabola. They're all flat surfaces about the same width.
Mm-hmm.
Of course, one thing you don't want to do with cooking is when you're reflecting light, you don't really need a point source. Like if you're cooking with a pot, the reflectors should be about the same size as the pot,
Mm-hmm.
or maybe a little smaller. And then with this, the reflectors are roughly the same size as the cooker.
Sure.
Actually, what I did, we built one. I just found it in my shop and pulled it out yesterday
Uh-huh.
because I knew you were coming. And it had one of those, a tube about this long, and one of the smaller diameters.
Mm-hmm.
I can show it to you, and we had it on the stand, but it had a curved surface. It wasn't a perfect parabola, but it focused a line of light onto the tube. So you had this heat concentration in the line. So just this morning, I poured hot water into it, and the tube broke.
Oh no.
Because I think there was so much thermal stress,
Yeah.
because it concentrated the heat
Yeah.
all on that one line.
Yeah.
And it was a mess to clean it up.
No.
So these tubes here, if you notice, these are sealed in plastic. I wrapped vinyl around it, so if it did break, it wouldn't shoot all over the place. Because I forget.
Yeah.
You know, we did a lot of different things with those tubes.
Mm-hmm.
One of the things we did, you know, we sold refrigerators to the developing world
Mm-hmm.
for storing vaccines. And one of the big problems is they have sharps waste,
Right.
and what to do with the sharps waste. So what we did, we made this thing out of one. They have tubes about this long and that fat.
Mm-hmm.
You've probably seen them,
Yes.
evacuated tubes. So what we did, we made a gadget. You drop your sharp waste in there. I don't have it here.
Into the actual tube?
Yeah,
Okay.
and then we have a way you put it out in the sun with a couple of reflectors,
Okay.
and then it melts it sterilizes and melts the plastic, and the needles
Wow.
get submerged.
Oh, and the needles. Oh man. Wow. You gotta make sure that gets done. Good shot of that.
We never could, you know, even though everybody writes about how much of a problem it is, you couldn't get any real interest.
No, and it's such a, and it's,
They're only interested in putting money into the vaccines, not the waste.
right.
So we could do it, now we could do it with solar electric too.
Yeah.
It might be more convenient.
I think that's the first example I've heard of actually making the medical waste safe versus like an autoclave for like surgical instruments, which I've heard of some people using various solar devices to bring them up to the heat where it would be sadness.
We also use one of those short, I can show it to you, those short tubes. We made a solar vaporizer
Oh wow.
for smoking marijuana.
Okay, sure. You know,
It worked really well.
it's probably is about half the states are at that point where it, you know, it might as well.
It created really uniform temperatures.
Sure. Okay, so you're setting it there.
This is our solar vaporizer.
A solar vaporizer.
It also can melt those syringes.
All right.
So what you would do, you put your marijuana on here, whatever you're vaporizing, and you just hook these tubes up. I don't actually smoke very often, but I thought it'd be cool to build this. So this is it. So you'd suck on this, and then you get, here's a thermometer, you can get it up to like 350 degrees.
It would just be pure vapor coming from whatever you have in there.
Yeah.
Let's just say, for instance, marijuana.
Yeah. Or anything.
Anything,
People
yeah.
vaporize other
Yeah.
stuff too.
Yeah.
Yeah.
Wow. And that's just the one. That's a fairly standard vacuum tube. I've seen those
Well,
sizes.
these tubes were made originally, some company made them. They had these samples of domestic hot water system.
Sure.
They'd have about 6 of these in a sample, and it would be show you how it works.
Sure. Cool. Okay.
So, if you can photograph this.
Oh yeah.
This was our literature.
Here we'll do a still. We'll do it like this.
We sold a couple of them, but not much.
Okay. And the other side, or is it? Okay. We'll get that, and that'll just be that'll work. Okay. Okay. Well, and I see another vacuum tube cooker out there.
Yeah, oh here, this is a vestige. You see that pressure cooker?
Which one?
This old thing.
Oh, that thing, sure.
That's a vestige of the first cooker I ever built. It had a, I think it was 1 foot by 5 foot. I don't know if you ever heard of a big fin.
Of a what?
Big fin. Do you ever hear of Zomeworks, Steve Bear?
Steve Bear, yes.
Yeah, he made this thing a long time ago. It was a product, it was like a fin about this wide, and you snapped a 3/4 inch copper tube into it. So we used that and added some more metal to it. So we had this collector 1 foot by 6 foot with a tube in the middle, and then a little tank at the end. So we could make steam in there.
Sure.
And then we had a flexible tube that went into the pressure cooker.
Oh yeah.
Wasn't very practical, but it did work.
Do you have pictures or videos of any of that?
No, like I told you.
Yeah. Okay.
I was real bad on it. I'm a photographer too, and I can't believe I don't have pictures of them.
Believe you, you're not alone. Pretty much everyone that does the tinkering with an idea, until they get to the point where, oh man, now it is cooking, then they might take a snapshot of it. Very few will do a whole video of it. That's one reason I started doing this, was because I just knew of so many that were developing really cool, mostly solar thermal cookers, that there was nowhere else where it was being recorded. You know, I heard about it. It was maybe written up in text on the SCI wiki, but they didn't have pictures, or maybe one picture, and it was like that wasn't enough. And so, I wanted to get more of the story. So.
Oh yeah, that's good.
Yeah.
There's so many varieties of solar cookers.
Yeah.
That's nice. So what else do we have in here? So basically with one solar panel in the developing world, you could run your whole house, do
Yeah.
all your cooking, refrigeration, charge your phone.
Yeah.
And then we did start using a battery because a friend of mine, I don't know if you know him, Johnny Weiss.
No.
He started Solar Energy International, and he's working with the Indians on some of the reservations, and they need cookers, but they cook a lot of mutton in the Navajo reservation, so they need something for boiling simmer cooking, and they have a little more money than the people in Africa. So this way, with a battery, you could cook conveniently at night or in the morning.
Sure.
So we added that feature. The lithium-ion batteries are getting cheaper.
Mm-hmm.
I saw one that's at good reviews. It was only $325
Oh yeah.
for a kilowatt hour. We paid about $900 for that one.
Yeah. But yeah, it'd be cool if we could do the one other vacuum tube outside. Yeah. Well, could you do 2 minutes on this? Just
Yeah.
Yeah. What was it? What was the idea? And
Oh, the idea was a preheater, like if you're in a developing world
Mhm.
and you were going to do some boil and simmer cooking, you could start out with really hot water, say 180-degree water or something like that, and then it would take very little energy to boost it up to boiling.
Sure.
So what it had, this is a little tank up here. So the water would, this is like the preheater. It would go up here and then it would go down into the top of this evacuated tube, and then it would get heated more and then come out from at the bottom.
Sure.
Which doesn't work as good as I want to do. I don't know if it's practical. And then I don't know about evacuated tubes in the developing world,
Yeah.
just because they can break. I broke in a number of them.
We've all been there. I was roasting coffee beans in one,
Oh, yeah.
and it worked great, and you'd see the steam coming out. And I just used 2 flat reflectors to boost it up a little bit. And what happened was enough of the moisture had collected at a certain point where it was hot, but the lip was just beyond the reflectors, the lip of the tube. And so when I poured out the water, the temperature differential, that's exactly where it shattered. So,
Oh, it broke because
Yeah.
of the water temperature difference.
yeah, it was so straightforward. I'm looking and going, I should have just left well enough alone, let it evaporate on its own. But yeah.
Speaking of evaporation,
Yep.
see what this thing is?
No. Here, I gotta before you say anything, get cameras pointed again. That's my biggest challenge, is that, especially when you got multiple angles here. Okay.
What is it?
Yeah, what is it? Solar dryer, I bet.
Yeah,
Yeah?
that's close.
Okay.
Well, we're by the ocean.
Right. Oh, desalination.
Yeah, it's for making, not desalination, salination. We're making sea salt.
Oh, okay.
So you put water in, and there's a tray in here.
Mm-hmm.
So you put water in the tray, and then in a few days it evaporates and you have sea salt.
I heard of a woman in New York City doing that, where
Oh, yeah.
she'd have to get a 10, 20 gallon bucket or something, and
Mhm.
I think she had like one of those big trike bicycle pedal
I wish
things.
you would evaporate it with her heat.
But she brought it up to somehow got it up to her apartment. She must have had an elevator, because that would have been
Yeah.
easy to carry out. But she made salt
Oh,
right
wow.
from the seawater.
Yeah.
Yeah. Cool. Okay.
Pretty easy. What about this dryer?
Okay. Yeah. Let's look at the dryer. Hang on. Once again. Get that pointed there. This guy. Okay, yeah. Right back here. Okay.
So, you know, a typical solar dryer, it heats, there's like a tunnel where it heats up the hot air, and then it rises up through the food. But after it leaves the food, it's still pretty hot and has the potential to evaporate in the food. So if you could recirculate the air, you could use the energy more efficiently.
Sure.
Collect it. So the idea with this is the it recirculates the air. The air, these are air collectors, this thing and this thing, and then it's a reflector to increase the insulation. So the air comes down. There's two fans down below that suck the air down. So the air goes down like this, and then it goes up through this grate, and then up through the food and comes back up here. We never used it very much because it was stupid. I should have used it more. But because this is the same problem the guy pointed out at that solar conference we went to, is that I asked this question and he didn't know the answer. He said it's complicated. So the question was, see, there's also a fan that can blow outside air into the cooker, into the dryer. So you don't want to have zero outside air enter it because the humidity would go up to 100%.
Right, and it'll stay inside.
So you want to know what's the optimal amount of air to add. So I didn't know that.
Yeah. When it
I have
depends.
some ideas now how to do it, but I'm not sure that would work.
And it would have to be a matter too, like in Minnesota, the summers are fairly humid. They're not like Washington D.C. or New Orleans, but they're fairly humid.
Yeah.
Whereas in the winter, it's really dry. So theoretically, you could dry things much more efficiently in the winter because you could put that air in there. You just have to make sure it's the right heat to without being too hot, so you're not cooking, but you're actually drying. Right?
Right. My latest thought on how to optimize it, you'd have two thermometers, measure the air temperature, and then you'd have another probe inserted into the food. So when you have evaporation, it cools stuff off. So I'm not sure this would work, but I think it would. So if you maximize the temperature difference between the air and the food, you'd be evaporating the most amount of water. You might optimize the performance.
You know, you're mentioning that brings to mind, there was a time when our part of Minneapolis got hit by a big hailstorm, and people got new roofs because it wrecked roofs and put in skylights, but a bunch of people's trees got blown down too. And I had one walnut tree cut up into lumber, because of course black walnut, just rich wood. And I studied up on how can I just dry it myself? I don't want to.
The same problem in drying.
Yeah, and so I got a wood hydrometer thing with two prongs.
Oh right.
And you just stuck it into the board, and it just went in far enough. Basically, that's how the further you needed to go.
Yeah.
And it would give you the moisture content, percentage or whatever.
Right.
And it had to be a certain range. It couldn't be ultimately dry, otherwise it'd be like powder.
Oh yeah.
But down to, I don't know, I'm gonna make it up, but like say 5%.
That's pretty dry.
Yeah, that's pretty dry. So 15%.
Yeah.
But what that brings up is there the equivalent for food, where could you stick that into, well, sometimes you're drying leaves, and so.
Yeah, but it wouldn't tell you. Oh, it'd be hardwood, I'm saying, if you're doing leaves.
Yeah, well, yeah. Well, so like tomatoes, let's say, or apple slices.
Tomato you could still put
Yeah, and maybe this wood thing would work with it. I still have it. I should try that because we do have a.
But it wouldn't tell you how much fresh air, like it wouldn't answer the question.
Right.
But it would be. But it is a good idea to monitor.
Well, yeah, and you could, if you had like probes to these things, you could stick it in without compromising the flow part, and then you could do a slice of apple, try this amount of air, see how long it takes, then that amount of air, how much it takes, and have the relative humidity measured so you know, right?
Yeah.
I'm on the right track?
No, maybe. Another thing, you don't want it to go too hot, like
Right.
above 140 or something.
Right, because then it's cooking rather than just...
Yeah.
Yeah.
So we put some apples in it today, about 2 o'clock.
Oh, wow. Okay.
So,
Oh, sure. Oh, and they look pretty darn close.
take one.
Oh, okay. Make sure I get one.
I'll draw it.
They're still chewy. They're not like crispy,
Then
but they don't have to be crispy.
they have
necessarily.
to, no, but to store them, it'll dry enough, you think?
I think they're still
A little
a little
wet.
more than what I'm used to from,
Uh-huh.
and that's of course from the store-bought ones, which maybe they're over-dried. I don't know.
No, it probably needs a little more drying.
Yeah. And so you got stuff inside the house, you said?
Yeah.
Yeah.
Oh, here's something else. What do you think this is?
Oh my goodness. Well, try another retained meat. Cooker?
No.
No?
We,
No idea.
we also, besides just heating things, we worked on passive cooling.
Okay.
So, you know about radiation?
Very little.
You know-
Major theater.
So every day when the sun's out, it
Mhm.
heats the earth up,
Right.
and the earth absorbs heat,
Right.
and it can't keep absorbing more and more heat, or it will get hotter and hotter and hotter.
Right.
So at night, it has to radiate. It radiates the heat out to outer space. And then the problem now is carbon dioxide is slowing that down. So it's not cooling off as much. So anyway, what this does, it uses, you can see how cold you can get some, the radiated heat cooling. So if it's a real clear, dry night, like moisture in the air stops radiation, stops the heat from radiating. So on a dry night, I've gotten this down to 20 degrees below temperature. It doesn't work good in humid climates.
So if it's a fairly dry climate and it's 40 degrees outside, ambient,
Yeah,
you can get it to freeze.
you could. You know, you could do a simple experiment. Just take a thermometer and put it on like a blanket
Right.
in a clearing. If you have a lot of trees around, you can put it on as much. And we have you see how cold you can get it. That's why you ever hear it's better to sleep under a tree.
I don't know that I've ever heard that before, but
Okay, it's because of the radiator cooling.
okay.
It won't cool down as much.
Now is that just one layer of aluminum foil, or is that?
Well, the idea was, it wasn't a great idea, but the idea is the cold air is heavy and it stays in here,
Right.
so you don't get as much. If this air is warmer, it won't
Sure.
heat it up as much. But the idea was, when this is radiating, if it radiates like that, it will bounce off the aluminum foil. So,
Okay.
but what happens sometimes is, in reality, if it's not real super dry, you get moisture condensing in the foils, and then it doesn't act like a reflector, like moisture doesn't reflect
Right.
it's infrared. Just a bare aluminum. But it still could get pretty cold.
Sure. Okay.
Oh, I got
Now inside.
well, I got one more thing.
Okay.
Oh, this was the thing for the syringes.
Oh yeah.
You would drop your syringes in here.
Okay, so literally you could just have like a little sharps cover
Yeah.
with those fins so that you don't stick your fingers in there.
Right.
Yeah, yeah,
And then you put this out in the sun.
yeah. Makes sense to me.
Uh-huh.
Yeah. Okay. Well, that's quite a bit right there. That's more than enough for me to have to edit once I get back to Minneapolis. And
Oh, you know one thing I want to talk about?
Mhm.
You measured temperature.
right.
One thing I wanted to, with solar cookers, when people say it has a certain, did you ever hear of mean radiant temperature?
Yeah.
Like in a house, your comfort depends on the air temperature
Mm-hmm.
and also the temperature of the radiating surfaces
Sure.
around your body.
Mm-hmm.
Well, the same with an oven, how fast you're going to cook depends on the air temperature and also the amount of radiation hitting it, like sunlight. Like you might not have, like if you had a box cooker, the air might not be that hot, but you have a lot of sun coming in and heating up the food. So if you just put a thermometer in there, it might not, you got to think about what you're actually measuring.
Yeah.
You're measuring the air temperature. I think ideally you'd have this little surface that would be the same color as the food you're cooking,
Mm-hmm.
and then you would measure its temperature.
Sure.
And then we could be influenced by the air temperature and also how much radiation is hitting it.
Yeah. There's a, I forget what the name of it is, but it's a solar cooker and it's a plastic case. Looks like a makeup case, you know, like for actors or for, women going out on a date.
Yeah.
And they have, it's maybe 6 or 8 bars that get progressively different colors. They're solid black, and then the inside of and it's a pad that you put the food on, and then it closes up and you don't close it up. It's a reflector, very small, but you can. I have put it out where that pad has gotten up to the 7th of the 8 bars, so and they have a little chart saying what the temperature of the surface of this pad is. And it's kind of like a heat sink pad that you put your pot on, and then you probably put a.
What's in the pad?
I have no idea.
Oh.
I have no idea. But I have 2 of them because they somehow came up on eBay.
They're flexible?
Yeah, it's really is kind of almost like a pillow. Maybe a little more solid.
You think
but
there's a phase change material?
I don't think so.
No.
I think it's more insulation, and then it's like a kind of like a nylon mesh thing on top that maybe because it's black, that's the idea, is that's a little bit of the heat would come off it. I have never cooked with it.
Do you put it in the sun?
Yeah, you just put it in the sun, and it opens up like a little tiny suitcase with a reflective mirror. It's
that's interesting.
Yeah,
and it keeps your food warm.
Yeah, it's probably just more. It probably is only good for keeping food warm versus actually cooking. But being the collector, I got to have it.
Right.
Yeah.
That's an interesting gadget.
Yeah.
Do you know the My Pillow guy?
I don't know, not personally, but I know very much about him because he's a Minnesota company.
Because you mentioned phase change material. I was wondering if they put that in the pillows.
I don't know. Does he have? Is it like the memory foam?
Well,
I don't get it because
just to keep it at a constant temperature or something.
Oh, that's a good theory.
I don't know.
Maybe it's patented and trademarked.
Yeah. You want to come in then?
Oh, sure. Let me turn these all off and.
You might want to photograph something in here.
Okay, I'll save this one for that.
You won't need a bunch of them.
Yep, and I'll bring this and I'll just set this over here so we know where it is.
So this is my kitchen. So what I have here is I have what's called a drain back system. It's a type of hot water system where you have a big tank, it's about this big, of unpressurized water. And then at the top of that tank, we have a heat exchanger. So from that heat exchanger, and it has storage, it can hold about a gallon. So it gets, after a certain length of time, it'll get to exactly the same temperature as the water in the tank.
Okay.
At the top of the tank. And then from that heat exchanger, there's a 1/4-inch tube that comes out to here. So if I'm making tea or rice or something, I have preheated hot water.
Didn't mean to touch that.
So now it was sunny today. I'll see what temperature it went up. It takes a minute to. not that hot. It's 142.
That's still pretty good.
Yeah, 143. So sometimes it goes up to 160.
Mhm.
So you can use that for cooking
Mhm.
or making tea
Oh yeah, yeah,
or anything like that.
sure,
And then I have all kinds of electric appliances,
sure.
similar to what I showed you, but I don't have the stove. You can see there's no stove.
Yeah.
Okay, I guess we're done.
Okay, thank you.
Yeah.
This has been great. I mean, especially, the variety and illustrating what you're after with the projects you're working on.
Yeah.
That's exactly what I want.